Hey, what's up guys, my name is Cherno. Welcome back to another code review, the series in which you guys send me your code and I take a look at it. The last two episodes we've been looking at C# code, so I thought I would bring it back to C++ for this episode here. Today, we are going to be looking at a Minecraft clone. Can you believe we still haven't done this? To be completely honest, I actually had to go back and check that we haven't done a Minecraft clone yet, just because it feels like something that would have come up by now. But I think we were just too busy looking at ray traces that people were sending in. Speaking of which, I have a new ray tracing series. The link will be up there if you are interested in learning about ray tracing and how to actually maybe write some decently performing code, like the stuff we've been looking at in this series, sorry, then definitely check out that series. But anyway, Minecraft. So, Istvan Horvath, probably butchering that name, has sent in a Minecraft clone in OpenGL called GLCraft. Very clever. Dear Cherno, please review my project. See, this is how you start a code review email. I want to learn how video games work and how to create one, so I recreated a very basic version of Minecraft. I'm Isti, a 20 years old university student. It was a great experience to create a game from scratch. I learned a lot. I watched a lot of Cherno videos for help and inspiration. I like how he calls them Cherno videos, not your videos. I watched a lot of Cherno videos for help and inspiration. I even checked out the Hazel 2D source to see how something should be implemented. But I did not copy paste anything, I promise. I don't know if this is a reference to like that bloom shader that someone just outright copied and pasted, but whatever. There are only two types of programmers: those who steal other people's code and those who lie about it. I don't think a single programmer, except possibly the first programmer in existence, has probably gone through their lives without actually just, you know, stealing a piece of someone's code, just, you know, under the table while no one notices. But anyway, it looks like this person has probably just been, you know, used it for kind of inspiration and maybe like design guidance or something like that. I didn't create a proper engine for the game because I think that the architecture that I created was sufficient for the game that I had in mind. Ooh, okay. I think from reading this, might be a good idea to kind of focus on the architecture of this actual code and talk a little bit about what it's like to actually architect a game instead of architecting an engine, because these days, everything is built on game engines, right? Like most games that come out, obviously, like they're not just like one-off kind of, let's open up, you know, C++ and just write a game. And the game contains the engine-ish, it's not really the engine. You just write a game in C++ without using some kind of engine. Like most games that come out these days are not made from scratch in the sense that they are made using tools that already exist, even if that tool was specifically made to make a game. So for that reason, I'm actually really interested to take a look at this and see how this kind of game has been made, because it's a very different decision when you're writing an engine and you're trying to make everything generic and abstract, like all of the kind of core components away. But then when you're making a game, you can be a lot more kind of free with like writing specific code instead of generic code, which in a lot of cases is really good. But also, even if you aren't writing an engine, I think that there has to be obviously some kind of balance between like writing OpenGL code, like, I don't know, GL draw elements or something, in places where nothing involving the renderer should be there at all, right? So you can still obviously make the mistake of coupling code and like intertwining code in places that where it shouldn't be. And just because you are actually architecting, you know, your software well, doesn't necessarily mean that you're trying to abstract it into an engine. So anyway, this will be interesting to take a look at. A house. Oof, there's a distinct lack of ambient occlusion here, which makes me upset. Thanks, I'll check it out. I love these suggestions. All right, I'm just skimming through the repository here. Link will be in the description below if you guys want to check out this project for yourselves as well. Building the project, how to build in CLine. We're not gonna be using CLine. How to build it using, okay, so CMake, we'll build it using CMake, I guess. Chunks are hollow on the inside, so most of the blocks that are not visible are not sent to the GPU. Yes, very, very important if you're making a Minecraft game. Otherwise, there's just too much data to render, and almost none of it is actually even needed. Each vertex in a chunk is only 4 bytes long to make the game as memory efficient as possible on the GPU side. Each vertex in a chunk is only 4 bytes long. Oh, okay. So I expect this means that he's packed the data, because like, you know, if you're drawing everything and everything is like a 1 by 1 meter block, you don't really need like, you know, to store everything in maximum kind of precision, because you know that you're going to be rendering, you know, triangles in a certain format, and they're essentially going to be laid out in this kind of voxel grid. So a good example is like traditionally, if you have like a 3D model, you might want to have like, you know, 3 floats, X, Y, Z, representing like a vertex, right? And so 3 floats would be 12 bytes. And that would just be a single vertex. And so if we were in fact drawing like a cube, we would obviously need like 8 unique vertex positions. And if we factor in like normals, we might end up with like 24 different vertices. However, technically speaking, if all we're drawing is an actual like cube and the whole world is made up of cubes, all we really need to know is like the integer coordinate of that cube, which could be encoded in a number of ways. It could be local to chunk space as well, if you wanted it to be. I guess that would mean that you didn't have to store very large numbers. I mean, you could probably get away with making, I mean, entertain this idea if you will. If it's local to chunk space and chunks are like 16 by 16, then you really only need like 4 bits to encode that chunk coordinate, because 4 bits gets you like 0 to 15, and that can be like the index. So 444, so you basically end up going from like 12 bytes to 12 bits worth of data to represent just that one vertex. But the vertex, like the cube is such a predictable shape that you don't really need to like store all of the individual vertices. You could just send that one coordinate to the GPU and then expand it using like a mesh shader, or, I mean, it doesn't even have to be that complicated. You could just expand it in the vertex shader. I suspect that's what that means. So that's interesting. I think we can definitely take a look at that. Although I did promise architecture, and this video has to be a finite length, unfortunately. So we'll see how far we get. Okay, and libraries used fast noise light for terrain generation. Okay, fast noise, yep. So it's just like a Perlin / other noise kind of generation algorithms packed into there. GLAD for loading OpenGL. Okay, so yeah, OpenGL. Yeah, GLAD, GLFW, GLM, pretty standard. I'm GUI and load PNG, which I haven't heard of. I wonder why you used this instead of just STB image. I guess maybe this is a bit lighter because it's only PNG or something. But maybe it's faster because STB image is not the fastest thing. Anyway, whatever. Let's get into the project. Okay, so what I've done is I've just cloned it using Git, of course, and then just built the project files using CMake, and here we go. Failed to open file, default.glc. Great start, but it seems to work. Let's take a look at this. Ooh, okay, I'm GUI. Oh, okay, so escape locks the mouse, or I guess brings up that menu and also unlocks it. Okay, cool. Yeah, I mean, look, this is working, and I didn't even have any problems getting it to build, so that's nice. Okay, we got the block outline. Mouse feels very, like, sensitive. Whoa. Place remove blocks. Seems to work. Let me just dig a tunnel. Okay, so you can just fly through, and yep, you can see that none of the back faces are being rendered, and no blocks that are actually not visible, right? So invisible blocks are not being rendered at all. Oh, okay, I guess this is how we select blocks to place. We can just, like, oh, there we go. We just have to go to this and select it. Very cool UI, very high tech. Okay, oh, the speed of this. Well, the lighting's kind of interesting because it's not very smooth. It's just like, it's as if there's like a few different states of lighting. That's interesting. Enable physics. I like how it's in quotes. Physics. Yeah, I guess it's a bit not really correct physics or something. Okay, so let's see if we can, okay, I'm stuck. The physics are beautiful. I can't, unfortunately, I can't hold space to jump. It's very annoying. It's so fast. I made it very fast. Cool. I mean, yeah, it seems to work. I'd love to just be able to, let's disable physics. It'd be cool if we could like fly faster, but I can't seem to get that to work because I'm interested in like just flying really, really fast and seeing like how well the terrain generator can keep up with that. Maybe we'll... Anyway, I'm going to try and not turn this into like an optimization series and like explain how I would do this better because that's whatever. All right, so digging into the code, let's see what we've got. So looking at the projects here. So you've separated out every submodule into separate kind of things here, which is good, I guess. Oh wow, load PNG is quite big. That's interesting. STB image is all kind of in a header file, but I feel like all of the codecs are like the size of all of this code. So this is interesting. I've never looked at this library before, but yeah, interesting. Oh well, maybe it is. Maybe it's nice and fast though. Okay. Anyway, so all the modules are here, but I don't like the fact that this is called main. Like, why is this called main? Like, you could have at least called this like jailcraft or something, but it's just called main. I mean, I guess it makes sense in a way. It's kind of, it makes it easy for me to find, but yeah, I'd probably name it something a bit more sensible. And then we've got all this stuff here. Where are like your header files? Let me just switch to this mode. Oh, they're just here. Where are all of the header files? Where are they? This is super weird. So they're all here in source. They are in fact next to everything. Well, yeah, these are going to be all linked because it's a CMake project, which means none of these are probably even relative to, yeah, so they're not actually here. They're back at directory and inside source. But why are the header files not showing up? That's like super annoying. You can't see the header files here. I don't know, man. What's going on? What's going on, bro? Like, you need to see a header file. All right, main.cpp. Cool. Let's start kind of taking a look at all of this architecture. Okay, default.glc. So that was probably the save file that it failed to load in the very beginning when it actually tried to, I guess, load the save file and it didn't find it. Sure. So that's kind of the save path, and then we try and load this, and then we do application instance to get the app. Okay, cool. So you're kind of using like a singleton approach here. I wouldn't do this because it doesn't seem like it's necessary. I also don't really like the fact that this is just kind of, so you've made like a static application. It's tied to this kind of, it's like a local static thing, which means that the first time this runs, it will actually instantiate it. And like, I don't know, I use this for like, basically, I only use this approach of creating objects for like debug utils that I want to like lazy load or lazy initialize, kind of like this. Application is such a like important part of your application that like why not, you know, just kind of create it here. Like the thing is, even if you do it this way, there's nothing to stop you from like, you know, using this as a singleton still, right? Like you could, for example, in the constructor, just store like, you know, so in the constructor over here, we could have like a static application, you know, S instance or something, which we could initialize to null. And then when the constructor actually gets called the first time, then we could set it to like this. I hate this Clang format thing destroying everything. But anyway, so you could just set it to like this, right? And then that way, obviously, you could return that inside your instance function or whatever. I don't know. This doesn't sit well with me. And I guess the reason is that I just think that such an important part of your project should be clearly defined where it actually gets created. Because the thing is, like, again, you're not doing much in your application, so it's probably okay. It's probably not a huge deal. And to be honest, you'll probably hear me say that a lot about all this stuff because I'm just picturing like when I see like application and this is like the whole application and you run it here, right? Like I'm kind of in my head, I'm comparing it to maybe like a game engine like Hazel or something, right? And so obviously like the application class there is going to be a lot bigger and heavier and more important than your application class, which doesn't even seem to do much stuff in the constructor. However, it's still something that like I would kind of, like from a design point of view, it would be nice to be able to kind of create it explicitly instead of having this kind of lazy load situation where whoever happens to call instance first, it gets created then. And also it's not really clear because that's the other thing, right? If you're making it this way, it's really not clear at all when the application destructor will get called and when the application gets shut down. Because this effectively is a static variable, which means during like static shutdown or whatever, that's when it would destroy it, which is basically going to be like at the end of the main function, right? But in no predictable order. Now, if we quickly compare this to Hazel just for reference, then you can see that like in the main function, it's extremely explicit when the app gets created, when the app gets run, and when the app gets deleted, right? This is all very, very explicit because it's such a major part that you really want to be clear with like, okay, it gets created here and I should initialize everything. It gets destroyed here and everything should be shut down. So that's just something that I would have liked to have seen here. Okay, whatever. So we create it, we set the scene to whatever the safe path is. I'm assuming if that doesn't, in fact, like if it doesn't load or anything, because it can't, because the safe path isn't a thing. Make shed persistence. What on earth is this? Persistence. What is this? Persistence. I guess this is supposed to be something that, what, persists? Commit chunk, and then it stores the chunk. Persistence. Whoa, what an interesting class name. Now, one thing that I don't really like about this, okay, so from a code style point of view, I would rewrite this class pretty much entirely. Like literally, I think it would be faster if I just would show you how I would write it. So first of all, okay, so let's not change the functionality, step one. What I would do is I would move this stuff, which is implicitly private, right? We can't tell it's private. Like there's no private label here because it's a class, which means that if you don't specify a label, it's private by default. I always specify a label though, because that just adds readability, right? So that you can actually see the visibility of your variables. And also because, to be honest, it's like a bit of a magic thing. Magic in the sense that like, well, if you don't specify a label, then it's obviously implicitly private, just like it would be public if it was a struct. But then as soon as you specify a label, then obviously everything is public under this label. So it's kind of like a weird state where if you don't do anything, if you don't touch it, then it's going to be private. So I don't really like that. So what I would do is I would always add a label, but also I would move this and store it down here. Why? Because usually when you look at a class, and this is probably like the kind of game engine / like API maybe developer in me saying this, but I like to look at a class and see what its API lets me do, which obviously is the public contents of that class, right? So stuff that is private is kind of an implementation detail, you could say, because I don't like to use this class. I just need to know what functions I can call, basically, right? Or what data it contains if that data is public. How it works internally and what it stores and whatever other private functions it might call itself, that is completely meaningless to me because I only care about what I can actually use. That's why I personally like to start a class with the public methods, variables, whatever. You have an explicit constructor up here. I noticed that you've been making a lot of constructors explicit. Like scene, I noticed also had an explicit constructor. Don't exactly know why that is. I wouldn't make a constructor explicit unless it was like maybe some kind of math type or something that like I mean, math type is actually a good example of implicit constructors and why you would want them, right? But in general, like if there was like a reason to make it explicit, meaning that like there was some kind of, you know, implicit conversion that is common and that was messing something up, or it was like, I don't know, it's not very common, to be honest, that I've had to use explicit, but implicit constructors can just simplify code a lot. And for those who don't know what an explicit constructor is, it basically means that you can't implicitly construct this object by simply specifying this type. Whereas to me, like that word specifically means like there's a reason that I've marked this as explicit because it was ruined. It was messing with some other types that I didn't want to touch or something like that. Okay, then we have commit chunk, get chunk. So I don't like the fact that, again, this destructor, it's down here. I like to neatly have my constructors and destructors all in the same place, right? All in one place at the beginning. Constructors obviously construct the object. I would have like a copy constructor here if I needed it. You know, I would have a move constructor here if I needed it. All of the constructors are in one place and the destructor follows them. Let's move on to some of the other source files. ABB, access plane. Okay, so I'm assuming there's going to be quite a bit of math stuff. There has to be, right? Because obviously you have to, well, for one, you have to place and remove blocks, right? So there's array class here. Then we have these access planes. So what on earth is this? Access plane, plane normal, array position, array direction, access plane. Okay, plane normal. Calculate offset direction. So a whole bunch of math here. Intersect, dot, plane normal, array direction. So this is like kind of like a plane equation, I'm assuming. That's why you got the plane normal. And then this is going to return, I guess, the distance of intersection on there. By the way, if this kind of math is confusing to you, then like there's no reason that it has to be confusing. You can just learn all about it if you head over to Brilliant. For those of you who don't know, Brilliant is an amazing website filled with really, really good courses on various STEM topics. And I particularly love their math courses. Unlike other course websites, Brilliant's courses are extremely interactive and engaging. They quiz you, they ask you questions about certain things to make sure that you're actually learning stuff. They give you like these sliders that you can play with and just heaps of like interactive controls so that you can visualize what you're learning better. And to be honest, that's how I learn best, visually and by practice. Aside from math, Brilliant also has a lot of really good computer science courses on topics such as data structures. And the best thing is that you can get started with Brilliant for free. Just go to my link in the description below and check out their amazing classes for yourselves. And if you like them, Brilliant have been amazing enough to offer the first 200 subscribers who sign up using my link in the description below 20% off an annual membership. Huge thank you to Brilliant for sponsoring this video. All right, so taking a look at the Ray class, what seems to be happening here is that you have a constructor, not explicit, that's good, which takes in a position, a direction, and the world, and the reach, which I'm assuming is like the maximum distance of the ray. This is kind of an interesting design, and it's a little bit weird to me because like a ray in my mind just represents like literally a mathematical like equation, right? Like you're casting a ray into the world and you're seeing what it hits. To me, that's like a problem to do with numbers. You're literally doing some calculating. Whereas what you're doing is you're actually passing in the world. And so this is extremely specific to this world, right? So it has to actually, I guess, use the context of this world to figure out what blocks you can actually hit and what you're intersecting with. And then you can see that it's even tied to like certain things like air, right? So if it hits the air, then obviously that's not a valid block to hit. So we're not going to set successful to true and do all of this stuff. This is actually a really good example of being super specific to suit your needs. And in my opinion, this is a little bit too far. But if you think about it, like a ray class could be like the most generic thing ever, right? It's just, as I mentioned, it's just a mathematical set of numbers, right? And then you can do whatever you want with it. Maybe you have a ray versus ABB collision test, and that ABB maybe is in world space, and so you need to maybe transform it into ray's local space or ray into world space or whatever, right? You do all of that conversion kind of as you need it. However, it could be as specific as this, where you literally, like when you construct a ray, it immediately actually does the math in your specific world, knowing all about your specific block types. Now, why is this a bad thing? Well, it's not exactly a bad thing, but the reason why it's a bit weird is because what happens when, for this same game, not saying you're building an engine here, but for this same game, you want to like open a door. Maybe you add some kind of like attacking feature, and if you're pointing like towards a mob or an enemy of some sort, you cast out a ray to see if you hit them, and that's going to trigger something. Like, how exactly are you going to, adapt this ray class to deal with all these cases? The constructor here is just going to keep growing. It's also extremely tightly tied to just being used for specific blocks. And the class itself just simply contains like successful and hit target, which I guess is like, I don't know if this is the position of the block or the position of the ray hit on the block, but then you've got obviously block data, which is like what kind of block it hits, and then like neighbor information. Like this is all, it's such a specific use case. Like at the very least, I would just simply construct a ray, like this, but then be like, maybe make like a cast function or something. And that way you could have like several different functions for specific use cases in your game. But like doing it in the constructor like this, like it's too narrow. It has one function and that's it. And again, as this inevitably grows, you would have to refactor it anyway. Now, the other thing that I think is important to note here is that when I construct an object, I don't generally, like, it depends what object it is. If it's like an application class instance or like a scene class, right? Maybe I expect that constructor to be somewhat heavy. But if it's like, a ray, I don't expect a ray constructor or any math type really to be heavy, right? Because I'm just constructing a little object. Maybe I can reuse it later. So for example, if I want to cast a bunch of rays, or I just have like one ray that permanently looks forward where the camera is facing, and I kind of construct that, but then I want to repeatedly cast it. I guess what I'm getting at is I just wouldn't expect the constructor to cast the ray. Like, simple as that. The other thing is, like, again, casting, like, the actual... So a ray, mathematically, that representation of, like, having kind of like an origin and a direction, like, that's all fine. But when you start bringing the world into it, to me, like, casting a ray is something that is... It's tied to the world, if you think about it, isn't it? Because if you just have a ray and then you're trying to cast this ray, and then obviously, like, where are you casting it into? Like, you're not casting it into the void. Like, you exist within an environment. You draw this line within that environment. Like, here we are. We're in a box. We're the player over here. And then what do? We cast this ray. So where is this ray being cast? This ray is being cast and potentially hits like a block within this kind of environment, right? Within this box. So this box is, in fact, the world. Now, how you've achieved this effectively is by creating this ray and then passing the world into the actual ray class so that you then know like what objects exist within that world or what blocks exist within that world so that you can do your kind of collision test. Now, to me, this is just such a backwards way of thinking about it, because to me, array just represents this line. You know, block represents a block. You know, player represents a player. They all exist within the world. So I would put that raycast function in the world class. Now, we can get really deep here. Honestly, I could spend hours talking about like object-oriented programming and like what to put into what class. But at the end of the day, like, I think you need to stop thinking of things as classes and start thinking of things as functions. It doesn't even matter really what class it's in. The reason why I would put it into the world is because the world, it has that context. It owns the blocks in the world. The player exists within the world. Therefore, if I mathematically shoot a ray in the world, it has all of that necessary context to actually see what the ray hits and where. Whereas what you've done here is you're basically shoving that context down the ray's throat because it needs all of this extra data in order to actually figure out what on earth it's hitting and what block type stuff is and all of that stuff. This actually wouldn't even be that much of a tightly kind of coupled function or whatever if it existed inside the world class. So yeah, like as far as this goes, just think of operations such as these as just like a function. Try and break down this project in a way just into its mathematical roots of like, I have a ray and I need to do a bunch of math on it to see whether or not it hits certain blocks and which blocks and how I can manipulate them and whatever else. Think of that as a function. Think about the inputs into that function. So in other words, stuff like the world, the ray, anything else, and think about your expected output of the function. Right? Think of it literally in the most basic terms possible, because at the end of the day, what you're doing is you're making your CPU execute this kind of function that is going to take some kind of input, crunch some numbers, generate an output that basically says, hey, this was successful as you were putting it, which basically means I hit something, and here is the associated data that you might need, such as like which block you hit. And then once you've kind of gone through that in your mind and you know exactly what you're doing, then you can think about like, where does this belong within my code? Because again, like, I mean, maybe you had a great reason for this, I'm just not seeing it, and that's totally fine. But to me, this just looks like you're just maybe struggling a little bit with deciding where code kind of should be, and I guess like how a good way to dress it up is. And to be honest, that's like another huge issue that I notice a lot with people who are both learning programming, but also kind of maybe get a little bit too tied down into like the object-oriented paradigm. And that is the fact that like the name of the class begins to, in a way, imply certain behaviors. And in your mind, perhaps, you're trying to like assign certain behaviors to certain classes. If you stop thinking in that kind of object-oriented way, where you have like a class for each of your like, I don't know, high-level nouns in your like story that is in your UML diagram and all of that absolute rubbish that people say, mostly like corporate managers and universities maybe, and you start thinking a little bit more about like the data and what actually needs to be done and try and simplify that as much as possible, then I think that you probably will come up with better ways to sort some of this stuff out. Now, moving on here, as usual, I think we're running out of time, but let's just like click on some random files and see what I can find here. Okay, so the scene class is something that we use to kind of control like the game logic, because there's also a world class. So this kind of seems a little bit confusing to me, but I think I kind of get your drift, where the world kind of contains like the world generator, and I'm assuming all of the actual world data, or maybe that's inside the world generator. No, that's just seed and noise, sure. But I guess all of the actual, so where are the chunks stored? Up here, chunks, right? So you have an arnold map of ivec2, which I guess is just an XY kind of coordinate for that chunk, because the chunks kind of are two-dimensional in the sense that like these aren't blocks, these are chunks, right? And then we have a ref to a chunk. Okay, so that's a heap allocated object there. And then we have hash vec2, which is just a particular hash that you use for that unordered map for your ivec2, sure. So the world class again is the thing that specifically stores all of your chunks, whereas scene is kind of like your game manager. And then from there, obviously we call update, that updates the player, the world, all of that kind of stuff. I'm just gonna briefly look through all of this stuff. What is going on here, bro? If key equals 87 or key equals 265, Why are you using integers for all this stuff? Damn, this took a turn. So you're using GLW, which actually comes with constants for all of these things, right? So like GLW key, I don't know, W, for example. Now, if for whatever reason, maybe you don't want to include GLW in here, and perhaps that's why you're doing this, then that's absolutely not a reason at all, because what I would do is I would just take, you know, all of this stuff, copy it basically, put it into a header file inside your actual project called like, I don't know, key codes, and then reference those, because this is just wild. Having comments here for like, you know, for just random numbers basically that map to key codes. Like, that's intense. This kind of like threw me off. Like, I don't know. This is this is weird because, you know, all of your other code just seems so much kind of, you know, above this level where we're still doing this stuff. Now, then what you do, okay, so you have action. Action equals 1. So set is camera moving forward. And then forward dot is moving equals is moving. Forward is a movement direction, which is an is moving followed by a direction. Oh my goodness, what is going on here? Bro, you really need like a camera tutorial or like a movement tutorial or something. This is intense. You know, I always say that before you Google something, you know, if you have the time, it's nice to try and implement it yourself. And I mean, back when I first started programming, I used to go crazy with, I used to just, I guess, force myself to come up with my own personal implementation and solution to all of these various problems. And some of the solutions I came up with back when I was like in high school and had a few months of programming experience, they were whack. They were ridiculous. But it was cool because I was able to actually solve the problem myself. And yes, I did it in a garbage way, but I did it myself. And I think that's an important step to learning. So if that's what's going on here, then cool. I'm glad you tried this yourself. Now let's talk about why this is weird and what I would do instead. So first of all, what you probably should do, what you are doing actually, is you have a bunch of predefined vectors. Right? So this is like the forward direction, which seems to be on the x-axis. Then we have backwards, right? Which is the negative kind of x-axis and all this stuff. You also have Boolean states for all of these, which again is a little bit weird, but I can maybe see why you're doing this. I'm assuming it's because you can move, say, forward and left and up at the same time. And so that's why you kind of have these states here so that you can check to see which way you're moving. But again, I don't know. I just don't know why this is happening. Because what you could do is you could just have something like extremely simple here, such as like, I don't know, my velocity, and we could like just initialize that to 0 or whatever. And then obviously if we move forward, then all we have to do is say that like we're going to move in whatever we decide like a forward direction is, which could be like, I guess you were using 1. At the very end, if we wanted to make sure that, you know, we were moving like, so let's just say we go left, which left was sure on the z-axis apparently. If we did something like that, then like, oh no, we're moving too fast or whatever, you could always, if you wanted to, take this and like, I don't know, normalize it in the end or something, make sure it's a unit vector. That way your speed really is 1, no matter how many directions you're holding. Not that this is a good way to write like an FPS camera in general, because you would want to probably move in the direction of the rotation, of the orientation, which I'm assuming you do anyway, because obviously that was working, but I guess this is just like, kind of like, where is your intention to move? Is it forward? If so, then set that to true or whatever. But again, kind of ridiculous. I would just do the calculating actually here and then just like basically be like camera.set velocity. And again, it doesn't matter if we're moving up or down or left or right or whatever, because we know which way we're moving. We have that kind of mathematical vector instead of this kind of like logic kind of state tree, which is kind of what you've created here. The other thing is, again, like just like with these weird numbers, code is supposed to be self-documenting. You want to document the code as much as possible, meaning that when you have something like this, instead of repeating this many times, action equals 1 clearly means that the key is pressed. So just make a boolean called key pressed and just set it equal to action equals 1. We could just rename this to like is pressed or whatever, and then that way it's just like are we moving? Is pressed. And I mean, you could make it even less ambiguous than that. I mean, we have is moving, so you could even set this to is moving, and then that way obviously we would, you know, have is moving here instead of action equals 1. Right? Like, what does that mean? And I know what it means, but I'm saying that it could mean so much more if you just simply name this variable, just like you should name your key codes or use like the predefined definitions for them. Now, because this is a game and not an engine, it's interesting to see like World Render, for example, specifically using like OpenGL code. Like, oh, that just feels so weird to me. But like, again, that's totally fine, because this whole, like, the OpenGL is basically being used as the render API for this game, you know? So it's totally normal to have stuff like this, even though, you know, of course, the engine developer inside me wants to abstract this away, make it generic, make it so that we can implement any render API if we want to. Maybe put this at least into a renderer class or something, so that it's like we can specifically call stuff like renderer, you know, enable blending or whatever, if we're not creating pipelines and specific other things. But totally fine. Now, the last thing I kind of want to look at is, I guess, maybe block Vertex or something. So because you mentioned that, see, this is why it's weird, right? You mentioned you were doing cool like Vertex packing stuff, and yet you've got like this stuff. This is why it's so interesting to me. Like, it's just weird. Okay, so I found the shaders for drawing the actual blocks and everything. We've got default.vert, default.frag here. So we've got the vertex shader here, which is quite large. And so what it's doing is it's actually taking in a single attribute, right? Just one uint, a single uint. So we have 4 bytes here. And from there, you can see that we're extracting all of the information that we actually need, such as the XZ position of the block, UV coordinates, flags, all of that stuff, by just simply extracting bytes from that vertex data, right? So you can see like extract byte over here is going to basically isolate a specific byte at a specific offset. This is, I don't know why you've done it this way. This is actually kind of funny. I would just do, like, I would just, you know, move it by the offset first, and then just AND it by FF and show FFU unsigned. There's no need to like shift this all the way up, mask it out, and then shift it back the other way. Because if you're shifting something right, then the rightmost stuff that already existed there is gonna just drop off anyway. But anyway, so we're extracting these specific bytes. So again, XZ position is just gonna be, I guess, a value between 0 and 255. Same with UV coordinates, same with flags. Flags are just containing things like whether or not it's animated. And then we have, according to certain flags and some other stuff that we're extracting. So the Y position here has its own, so the first kind of byte, I guess, is the Y position, then the second byte is the XZ position, which I'm assuming, yeah, is stored kind of occupying just 4 bits, so between 0 and 15 for both of those things. So that way we just do some kind of bit masking and stuff to actually get the real XYZ position, which we then use as our vertex position, which eventually gets multiplied by the model view projection matrix. So basically, again, instead of actually having like layout location equals 0, blah, blah, in vec3, you know, vertex position, and this obviously, right, would occupy 12 bytes of memory because we have 3 floats. Each float is 4 bytes. This whole thing occupies 4 bytes of memory, and it doesn't just contain enough data for us to actually piece together this vertex position. It also contains the UV coordinates, which would be another like 8 bytes, right? Because that would be a vec2, and also any other flags that we might actually use. So obviously this is a huge saving. I mean, just these two together without the flags are 20 bytes of memory, whereas this is a 5 times reduction because it's only 4 bytes. So that's what he was talking about in terms of like just being a little bit smarter with the way that this kind of vertex data inside the vertex buffer is actually packed. So yeah, kind of cool. Now, of course, you could go a little bit more advanced. Like you ultimately don't even need a vertex buffer. You could just have like some kind of storage buffer, and then maybe like that could be written out by a compute shader, which will automatically generate the actual terrain mesh for you. You could really expand this, obviously, but it's pretty cool, obviously, seeing something that isn't just like your standard like in vec3 position, and then it's just kind of a waste for a voxel game like this where everything is so simplified. This is really making me want to make like my own Minecraft clone. And then over here in the fragment shader, we're able to like do the same thing kind of with the vertex UV. Now, the vertex UV is actually interesting because the actual like texture itself, obviously, this is ultimately like a sprite sheet. We have a coordinate of something that we want to access, right, within that atlas, that texture atlas, so we can divide it by 16 because 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 16 of these here. And then obviously like the vertex UVs are also kind of going to be predictable because it's all just arranged in a grid. So everything's really super easy when you're dealing with voxels and tiles like this. And you know, this guy's code has certainly taken advantage of that, which is awesome to see. So yeah, overall a really cool project. I enjoyed looking at it. Some questionable things, and obviously like the architecture, I would kind of give a little bit more thought to. I didn't take a look at the performance of this at all, and to be honest, I'm kind of glad I didn't. Not because I think it's bad or it's slow or whatever, just because I feel like that's what these code reviews inevitably become. Anyway, thank you guys for watching this video. If you enjoyed it, please don't forget to hit the like button below. If you want me to take a look at your code in the next episode of this code review series, then send it in to chernoreview@gmail.com. That email address and some instructions will be in the description below. Overall, a really cool project. I enjoyed looking at it. Some interesting like decisions when it comes to architecture that I think you could improve, but otherwise it was pretty good. And the Vertex packing stuff you did is definitely cool as well. Also, don't forget to take a look at Brilliant using the link below, and I will see you guys next time. Goodbye.